Converting values in code can be tricky. For example, if you rank something, you would say the top pick is in first place and not in one place. And the next one down would be in second place, not in two place. Those types of conversions are simple for humans to do, but they're tricky for software to do. Fortunately, the Humanizer package makes these types of conversions easy. From converting 4:30 p.m. to be 4:30 to knowing how to transform a string to be a specific enum value, this package seems to do it all. Let's build a small application to see more of what the Humanizer package can do in C#. So let's start with a new project, and this is Visual Studio 2022 Community Edition. This is the 17.5 version. Console application. We'll say Humanizer test and Humanizer test app. And .NET 7 is what we use. And the first thing we're going to do is we're going to add a NuGet package. So we're going to right-click on the dependencies and say Manage NuGet Packages and search for Humanizer. And we're going to get a lot of different versions of this. And don't be intimidated by this. There's a very clear reason why we have different versions. So first, there's the core version. The core version contains the library that actually does the Humanizer stuff, and it also contains the English language version of the results. So that's the one. If you just want to use English and just use Humanizer, this is the package to use. Now, if you want to use a different language, and exclusively that different language, you can choose that from this list of, I believe, like 36 or so languages. You get to choose, okay, I want Hungarian, and just choose that. Or if you want two languages, you can use Hungarian and, let's say, Portuguese, and install both packages. When you're installing one of these packages, or both, or multiple, what will happen is it will install the core version once, and then it will install just the language pack that you requested. Now, if you want to install all the different language packs, you can choose the overall Humanizer package. This is the one that installs every language as well as the core. Just note that when you're installing two or more packages, that they both use core, but you're not going to be duplicating core, meaning you're not going to have a version of core for Hungarian and another version of core for French. You're going to have just one version of core and then just the language packs. So that's what we're going to do. We're going to install just the core because we're not going to worry about languages today. We're just going to focus in on what it does. Hit OK. Now that that's installed, we can close this out and come back here and get rid of this code and say using Humanizer. And that will allow us to use the Humanizer package. We're going to say string test string. Now, this string stuff's not going to be terribly exciting at first, but we're going to just touch on this first just so you can see, okay, it messes with strings. But we're going to get on to some more interesting things to do with this test string. So we could say, this is my sentence, how, or let's go with, how do you think it went? Okay, that's a pretty messed up sentence. So let's just start with console write line, and we'll say test string dot transform. Now you can do transform, and let's put our extra bracket there. You can say to, and then say uppercase. You can say lowercase. These are things you can do in .NET, but you can definitely do those if you want. We have other things like title case. So if you do title case, let's run this, then we're going to get something like this, where it says, this is my sentence. Notice the T is capitalized, the I is capitalized, the M is capitalized, the S is capitalized, and so on, and the rest of the letters are not capitalized. There is an exception to this, and that is the went, which is all capitalized still. So I just want to make you aware of this. If you use these tools, then it's going to ignore all capital letter items. And that's because it's not sure if it's an acronym. For example, if this was HTML, we wouldn't want to have the H capitalized and the TML not capitalized because it's an acronym. And so we want to keep it all caps. So if it sees something that's all caps, it's going to assume that it's an acronym and leave it alone in the case of title case. The same is true for sentence case. Now, the sentence case is a little interesting. Let's copy this and paste this and look at sentence case. Because sentence case, what it's going to do, it may be confusing here, is it's going to capitalize the T at the very beginning, and that's it. It's all it's going to do. It actually doesn't touch the rest of the casing. So it looks a little weird here. And notice it also does not capitalize the H. The reason I bring this up is I want to make sure that you realize when you say sentence case, it's not talking about make this into sentences. It's capitalize the first letter of the entire string. That's all it's doing. It's not interpreting this into sentences. Now, the only reason I really bring these strings up is because there is a way to chain these together. This is where it gets a little more interesting than just what we have in .NET. So we want to do sentence case. We also want to have the rest of the things lowercase, right? We can say to dot lowercase and then comma and say to sentence case and transform the string twice. So if we run this, we'll see that now the T is capitalized and everything else is lowercase, including the went. So this has lowercase ignores all caps things. So therefore, it made us all lowercase, which may be a problem as HTML. But this just made the T capitalize everything else lowercase. So you can chain these together if that interests you. Okay, so that's kind of, let's get that out of the way and let's move on to the more interesting stuff Humanizer can do. Let's start with the idea that maybe you don't want our test string to be too long. Let's truncate it. And let's truncate it to an easy to count 10 characters. Let's run this. And we see this is m ... So if we count these characters, we see 1, 2, 3, 4, 5, 6, 7, 8, 9 characters. And then if we click on this, it's actually one character is a 10th. So this is how it counts the number of characters. It says, I'm assuming that when you say 10, you mean including the character that indicates that there's more to come. So, or I've been truncated. And it does this using the ellipsis character. And yes, it's one character. Now, in your test case, you might not see 3 dots here. You might see just 1 dot. And that's because your system is not supporting UTF-8. And you have to, even on Windows 10, you have to make a change. So I'm using PowerShell, and it supports UTF-8, but you also have to have Windows support UTF-8. You'll have to Google it. Essentially, you go into language settings and some advanced language settings, and in there, you say to use the, I think, beta version of UTF-8, which is a little frustrating that even now it's still a beta version. But that allows you to support UTF-8. And then you'll see this ellipsis. Otherwise, you'll see just a dot. Now, if you wanted to see that and you didn't want to turn all that on, what you can do instead is you can say debug.print. And then run this again. And when you do, nothing shows up here, but that's because we're not printing to the console. Instead, you come to the output and look and see there is the debug print version with the ellipsis, and that does even work when it's not turned on in Windows. So if you want to see it that way, that's fine. But maybe you say, you know what, let's undo this. There we go. Maybe you say, you know what, Tim, I don't want to have that single character ellipsis. I want to put my own. Maybe I want to create, 3 dots like an actual ellipsis would seem like would be 3 characters, right? Okay, no problem. You can put that right there, And now it says this is ... which is 3 characters. But also notice we now have 7 of our actual string characters here because we're taking up 3 with our ... If you say, well, I actually want 10 of my string characters, well, then you just add the number of characters you're putting here and add that on here. And maybe you don't want dots. Maybe you want, I don't know, stars. Like so. Then there you go. There's your 10 characters and then the 3 stars because you specified 13 characters. And again, you don't have to put 3. You can put 4 or 5. And if you wanted to still make it the 10 characters from our string, there you go. There's your ability to do that. So this truncate can be very helpful in certain circumstances where something might go beyond the length of what you're looking for. Okay. So, and just to be clear, what if I said hello and truncate to 15 characters? What would happen? It just says hello. So it's not going to put the extra characters at the end. It's not going to cause any problems. It's just going to put the string if it's less than the truncated value. This means that if you have potentially long paragraphs, but you want to say, I want to limit this to 50 characters, let's say, you could do that, and then paragraphs shorter than 50 characters wouldn't be truncated. Only the ones that go beyond that 50 character length would be truncated. So this allows you to be really flexible in how you process the truncation of these strings. And again, let's go ahead and comment this out because we have lots more fun stuff and it's not all just about strings. So let's create an enum. And we're going to do this at the bottom. Since we're in the program.cs file, you can create enums. You can create files. You can create lots of stuff in your program.cs, even though it's that top level statement. So we can say enum book. And you might say, well, why is it not public enum? Well, that's because this is actually a local enum. It's only available in this file. So if you want to make it available everywhere, you'd put it outside of this file. This is just for demo purposes. I would highly recommend that you only put stuff in program.cs that's just about running your application and allowing the code to execute your application be somewhere else. That's the best practice. But for demos, this is a great place to put it. So for our enum, we're going to say self-help, science fiction, math, and physics. And, you can, and this is not part of Humanizer, but you can put descriptions. I say description. Notice to add the using up here for system.component model. I can put a description on a particular enum. Something like that. And that would describe this math and physics enum value. So this, again, this is just part of C#. It's not part of the Humanizer package, but I wanted to have this description here because of what you're going to see in just a minute. So let's come up here to our console write line and say book.science fiction. All right, I'm just going to, there's no Humanizer here, just saying book.science fiction. What prints out in the console? Well, it prints out science fiction, which is cool. And if we change this to math and physics, just to be clear, it prints out math and physics. Okay, even though it has that description, it just prints out the math and physics. So let's go back to science fiction. So how do we make this more human readable? Well, we could say console write line book.science fiction and say Humanize. And let's put our closing parentheses and run this. And now it says science fiction with a space in between. Cool, but F should probably be capitalized, right? Well, don't forget, we've learned how to transform. Transform to title case. So now when we run this, we get science fiction 2 words. So it's figured out based upon the naming convention. Oh, these are 2 different words. And so it split them apart. And it made the second one lowercase, but we actually want it to be a title and therefore be title case. Therefore, we just ran the title case on it and get science fiction. But we're not done yet, because what about this one right here, the math and physics? Let's find out. Console write line, book.math and physics, humanize. Okay, we're not going to do transforms, just humanize. Let's see what happens. The scary math categories. So it knows there's a description there, and it says, hey, you know what? Since the description is there, that's probably what you mean when you say, I want the value. I want to print this out to the console, because it's meant to be read by humans. And that's what we get, what's meant to be read by humans. So really cool stuff there for humanizing your enum values. But we're not done, because you can go the other direction. Let's comment these out so we don't have too much stuff printed in the console. And we're going to say book type equals, let's start with science fiction. Notice 2 words, okay? I'm taking a string and saying this is 2 words and saying dehumanize, which is a little weird, to book. So I'm saying dehumanize to this enum. All right, let's go ahead and print out the book type. I'm not going to humanize it. We're going to leave it just as C# would print it out. And it says science fiction. So it knows this is the correct enum value. It knows that it's the science fiction value, even though we said science space fiction and even made the F capitalized. It can dehumanize that properly to a enum value. But we're not done. What if we said book type equals, and I'm going to copy and paste this just because it's a little bit long, this value, the scary math categories, dot dehumanize to book. All right. And again, we're going to print out book type. Again, this is the C# printing out. We're not using Humanizer. Math and physics. So it knows what enum value it is based upon either giving it the enum name with spacing, just fine, and even different casing if you want. It also can read the description that we give an enum value and say, hey, if you give me that description, then I can bring that back into a enum type, which also means that if you humanize something, like up here, where we humanized this category, and then that person gives us back that humanized value, we can dehumanize it back to the correct enum value. So really cool, we can go back and forth with that. But we're not done. So let's comment this out and keep going. Just note, you can't put code after the enum. All of your top level code needs to be before you do things like enums or methods and stuff like that. Okay, so let's now move on to working with time, because time needs to be humanized as well. Datetime dot now, and let's add days. We're going to add a day, and we're going to say humanize. So what do you think this will print out? Well, let's run it and find out. And it says 23 hours from now, which first of all, that's cool. It says 23 hours from now. That's a humanized value instead of just saying a value for date time. But that's not right, right? Well, technically it actually is. And the reason why is because we added 1 day here, but then by the time it gets to here, it's already slightly moved as far as the time goes. And so we're actually rounding down. We're rounding to the down to the nearest hour, and you can change the precision on this. But you can also do something like this. I'm doing very precise 1 day from right now. And so that's why it's being so specific. So if I were to add seconds, 1. Okay, so I've taken it's 1 day and 1 second, and then humanized it. It says tomorrow. So it knows about the fact that, today, tomorrow, yesterday, these kind of things, it knows about that. In fact, we can even show that. Let's copy this and paste this and say days -1. We can get rid of the seconds because it doesn't need it. And humanize that, and we'll see that we have tomorrow and yesterday. So it can convert the date time values into what we as humans would say. We wouldn't say, day -1. We wouldn't say the date necessarily. We'd say yesterday or tomorrow. I'm going to the store tomorrow, not I'm going to the store on March whatever. That's a little weird. We say tomorrow and yesterday and things like that. So pretty cool stuff there. You can also humanize other things as well. Let's just keep it for now and say console write line datetime.now add hours, and let's add 3.5 hours. And let's say humanize. And let's just run this. We see 3 hours from now. Again, humanized value, and it's rounding. Again, you can change the precision if you want, but 3 hours from now. Pretty cool, based upon the date and time. And you can, again, change this to be, adding 5 days and see what it says. So not everything is going to be humanizable or, clear, but most things will work like this. It's just knowing the precision and knowing if that's good for you, if you want to change it. So let's write another one, console write line, and we're going to say, let's go to time span. Time span from, not seconds, let's go to hours. From hours and say 42. And we're going to say humanize, like so. And let's comment these other ones out. So again, we're not having too many things print out on the console at once. And it says 1 day. Well, yeah, but that's not very precise. 42 hours from now. So let's change the precision. So for this, we can just say 2. What it's going to do is give me 2 different values. So it's going to be 2 values of precision. So not just days and hours. And if you want multiple values, you can go 3, 4, 5, 6, and so on. But 2 is all we need for this. 1 day, 18 hours. So it knows 24 hours plus 18 hours is 42 hours. It says, okay, 1 day, 18 hours is what we're looking at. All right. So we can humanize with our time span. So it gets even better than that, though. Let's come down here and we'll say console write line. We're going to create a new time only. This is the newer, we have date only and time only in C#. Well, there's new things you can do with time only. And let's say we're going to do 15:45. This is 15 hours and 45 minutes into the day, essentially. We're going to say to clock notation. Now, what do you think that's going to do? This is really cool. 1/4 to 4. This is how we as humans would say it, 1/4 to 4. We could also say, what if we change it to 30? And you run this. And now we get 3:30. Now, this only works on the quarter hours because that's what we do as humans. We talk about the things on the quarter hours, but we get all the fun values of the quarter hours. 3:15. So we can play with time only that way. But we're not done yet. Let's talk about something else. Let's talk about numbers. Console write line, and let's do 7843. 2 words. And you might say, what? Yep. 7,843. Now, when I was in school, my teacher would have said this is not correct. And the reason why is because of the and. This is how we say it as humans typically, even though, again, my teacher would have corrected me because of the fact that for true precision, if you want to be precise about or pedantic about it, you use the and to indicate the decimal point. So 7,843 and 43 would be 7843.43. But this, again, to be super precise, would indicate 7800.43. But when we say as humans, we typically put the and in there. But maybe you want to be precise. For example, if you're doing something for a bank, like writing this out on a check. Well, when you say two words, add false here for the add and. And if we run this again, we'll see that this one has 7,843. So that is the more precise version, even though that's the less common way humans say it. So, and maybe you learn something new, but we're not done yet. Let's come down here and say console write line and say 22 ordinal words. What's this? Oh, I think you're going to like it. 20th. This gives you your placing, 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, and so on. So if you want 5th place, cool. Now it says 5th. Okay, so again, you get to change your ordinal words, but we're not done. What if we had a number, let's just say 53, and say to Roman? This will convert it to Roman numerals. So that is LIII, also known as the next Super Bowl. But we just had a Super Bowl, and it was Super Bowl LII. But what is that number? From Roman. Because we don't remember how to read that. No problem. That was Super Bowl 52. So it can convert back and forth from Roman numerals. It can make you look really smart. Okay, let's keep going because, again, we're not done. There's a lot more that it can do. We're going to cover just a little bit more, though. And the next one up, we're going to create, let's say, var size equals 250 gigabytes. So what is size? Well, size is a humanizer.bytes.byte size. But we're taking a number, like our hard drive size, 250, and saying .gigabytes. Why does this matter? Well, we can say console write line size, which is this value right here, size.megabytes. And let's do one more, size.terabytes. So let's print this off and we'll see what values it is. We see we have a value of 256,000, or we have a value of 0.244 and so on. Now, why is this so impressive? Because we know that gigabytes is 1,000 megabytes, right? Well, no, it's not. It's actually 1,024 megabytes, which is why when you say 250 gigabytes, the number of megabytes is actually 256,000. We got an extra 6,000 megabytes compared to if we just said 250 times 1,000. And that 6,000 comes because that's the number of additional bytes that are in a gigabyte versus 1,000. So, and the same thing with terabytes. Notice that it's not 0.25, it's 0.244, and so on. So this gives you your actual values for your conversions. All right. So we can also come down here and say size humanize. Just give you the humanized version of this gigabytes, right? And it comes back as 250 GB for gigabytes, which is correct, but not terribly exciting since we just said 250 gigabytes. What if we decided to change this size, let's actually comment this out and say var size equals, oh, I don't know, 0.25 dot, well, we can't do that because that's a decimal number, right? Well, actually, we just need to wrap it in parentheses and then say dot terabytes, which, by the way, is the same as 250 gigabytes. And if we run this, we get 256 gigabytes. Why? Again, it's that conversion thing. But notice now it's 0.25 and it's 262144. So again, whatever value you give it, it's going to be precise about giving it back. And the Humanize didn't give us terabytes back, even though that's what we put into it, because that doesn't really make sense. Instead, since you said 0.25, you actually would probably read that as 256 gigabytes. So when you look at a laptop, you don't see 0.0 or 0.25 terabytes, you see 256 gigabytes. So that allows us to play around with and change versions of megabytes, gigabytes, terabytes, all the way down to bytes or even bits. So that allows us to play with sizing of our hard drives and such. But let's look at one last one. And this is just for fun, probably because probably most of you won't need this. I don't need this, but it's fun to know. Let's just say I have a 350, which is double. So D stands for double. 315, which is the number of degrees on the compass. Okay, so I'm looking at the compass and it says 315 degrees. But I want to know, what's that heading? It's a heading. And if we print this out, it's going to say, oh, that's NW. And I say, what's NW? I forget what that is. No worries. We can say heading style dot full instead of the abbreviation version. And now I get, oh, it's northwest. Okay, so I can tell what this is from the compass standpoint by just asking for the heading. But if I want to be even, have even more fun, I can say, yeah, but I have that 315 degrees, which D is not for degrees, it's for double. But I want to know what direction that points to heading arrow. Okay, and if I were to print this off, I get a question mark. Okay, well, that's because this actually comes off as a char. If I were to say to string and run this again, it still comes off this way. So what we can do instead is we can change this over to my debug.print. And oops, I need to keep that toString there. Let's run this again, and this time look at our output, and we'll see this little arrow here. It does point in the correct direction for northwest. So is that going to be terribly useful in your applications? Not unless you create a nautical application or an application for a flight control system. But it's kind of fun. So just so you know, there can be a conversion for that as well. So there's a ton of stuff that Humanizer does, and I've kind of blazed through all this stuff. What's the most important thing? Well, it depends on your application. But that's a cool thing, is that when you put Humanizer in your application, you have the ability to use whatever part you want, whichever one is most useful to you. Personally, for me, this enum stuff is really helpful because showing an enum on a drop-down list and being able to bring it back to an enum, sometimes I don't have control over having the value versus the display. Whatever the case may be, I can allow people to choose a value that then matches back up with an enum. Being able to say things like, I'll see you tomorrow, not I will see you on this precise day and time. Super helpful. Those kind of things. The numbers to words or to ordinal words, super helpful. I haven't used the to and from Roman, but that is actually kind of useful because every once in a while I have to know, hey, what's this number in Roman numerals? It doesn't come up often, but when it does, it's nice to be able to just pop that out. So if you ever had an app that needed that, you could do so. You can even create a little game about, guess the number and create, to and from Roman numerals. So there's a lot of stuff in Humanizer. If you have to do these kind of conversions, I think this is a great package to add to your project. Again, it's open source. It's fully available in the MIT license so that you can use it pretty much anywhere you need to, commercial or private applications. All right. Thanks for watching. If you have any questions, leave them down in the comments below. And as always, I am Tim Corey.